Morning, everybody. Today is Wednesday, September 21st, 2022. I am man with exploding to-do list, and today we're back and we're going to be doing more exorcism on we're going to be doing more Elixir on exorcism. And today we're going to be talking about protocols. Now, if you look at the concept doc for protocols, it's actually very terse. And so today I'm actually going to follow the Learn More link they have and go to the official Elixir guide on protocols and read through that a little bit. I feel like it's a little bit more thorough. So protocols are a mechanism to achieve polymorphism in Elixir, where you want behavior to vary depending on the data type. We are already familiar with one way of solving this type of problem via pattern matching and guard clauses. Consider the simple utility module that would tell us the type of input variable. This is where you declare a module called utility and you create multiple implementations of the type function, and then you use guard statements to say, like, when it's a binary, do this. When it's an integer, do this. In the use of this module, we were confined to your own. If the use of this module were confined to your own project, you would be able to keep defining new type functions for each new data type. However, this code could be problematic if it was shared as a dependency by multiple apps, because there would be no easy way to extend its functionality. This is where protocols can help us. Protocols allow us to extend the original behavior for as many types as we need. This is because dispatching on a protocol is available to any data type that has implemented the protocol. And the protocol can be implemented by anyone at any time. Here's how we could write the utility type function as a protocol. So here, you use the def protocol keyword, have utility, and you say, you're going to declare a type spec for the function. It's going to take any value t, and it's going to return the string type. And then, for each type, you say define implementation for utility for whatever type. In this case, a bit string or an integer. And then, based off of that value, it'll return, the string or the string integer. We define protocols using def protocol. Its functions and specs may look similar to interfaces or abstract base classes in other language. We can add as many implementations as we like using define impl. The output is exactly the same as if we had a single module with multiple functions. So that's how it looks when you call it. With protocols, however, we are no longer stuck to having continuously modify the same module to support more and more data types. For example, we could get the define impl calls above and spread them across multiple files, and Elixir will dispatch the execution to the appropriate implementation based on the data type. Functions defined in a protocol may have more than one input, but dispatching will always be based on the data type of the first input. So the first argument of the function is the one that's going to dictate which implementation actually gets called. That's really important. One of the most common protocols you encounter is the string.chars protocol, implementing the toString function for your own custom structs, which will tell the Elixir kernel how to represent them as strings. We will explore all built-in protocols later. For now, let's implement our own. And so they go through an implementation where they build a protocol called size, and then for different types, they implement the size of that data. And other thing to note, and they talk about this here too, is that in Elixir, there's the use of the word size versus length is intentional. So size is there when you have the value. Length is a word you use when you have to calculate the value. So for a list, you would have to use length because you basically need to count the amount of items in there, and that's like a runtime cost. But I'm going to skip some of those. I encourage you to read through it. I want to come down to the very end and just go through the built-in protocols, just to kind of give you an example, because it's kind of a callback to some of the other things we did. So Elixir ships with some built-in protocols. In previous chapters, we have discussed the enum module, which provides many functions that work with any data structure that implement the enumerable protocol. So for example, the enum module has these functions called map and reduce. They take a value, and sometimes it can be a list, sometimes it can be a range, sometimes it can be a map. So basically, the enumerable protocol, is there, and then those different data types like list and range implement the enumerable protocol, and this allows enum to kind of work with different data types. And yeah, I'm gonna skip all this, but this is a really great article. In general, like if you're working through the exercism track, I highly encourage you to kind of parallel read the Elixir guides. They're a little bit lengthier, but they do, like, they're good. They're a really good introduction to Elixir. So with all that done, we're gonna work on our example today, which is called Bread and Potions. You're developing your own role-playing video game. In your game, there are characters and items. One of the many actions you can do with an item is to make a character eat it. Note, not all items are editable, and not all editable items have the same effects on the character. Some items, when eaten, turn into a different item, e.g. you eat an apple and you're left with an apple core. To allow for all that flexibility, you decide to create an editable protocol that some of the items can implement. Alright, let's go. Alright, so I'm going to download. What's my tip of the day here? Assign an action to a smart selection rule, preps, profiles, advanced selection. I think on the Apple click. Apple click. I wonder what that means. I wonder if that means like shortcuts? No. They call it actions, right? Appearance, profiles. I'll have to look that up later. Badge, drawing. Yeah, I'll look that up later. Sorry. I am trying to get better at using iTerm2. Historically, I use just like the regular console. But I'm trying to stretch my legs a little. Okay, so that is that, and we're going to open up the test file over here, and we'll put the README down here, and we'll hide the sidebar. I want to run all the tests just to verify that they're all failing, and yes, they are. All right, cool. So we're going to get started. Number one, define the editable protocol. The protocol has one function, eat. The eat function accepts an item and a character and returns a byproduct and a character. Okay. I'm going to collapse these tests so that way we can just look at them. Task one. Okay. Alright, so define module. Add code to define the protocol and its implementation below here. Okay. So define protocol, and we were going to call this the editable protocol. And so this is going to be a function that says eat. And we can do a spec. Eat accepts any value, and it returns an item. We haven't really. Does editable always return an editable? Implement the editable protocol for the new. Oh wait, no. Task 1: create editable protocol. The protocol has one function, eat. The eat function accepts an item and a character, and returns a byproduct and a character. What's a byproduct? Returns a byproduct. Alright, so this is going to take an item and a character. Oh, they don't have. Alright, well I'm not going to use .t because they haven't defined types up there, so I'm just going to do it like this. Item, character, and do we need to do anything else? Define module, Yeah, we just say def type. We don't have to put any like trailing thing there. Okay. And then okay, so these should pass. Run all tests. Editable protocol eat 2. Oh, you gotta save. You gotta save. Edible? Oh, edible, not editable. Run all tests. Alright, that looks good. Okay. Make loaves of bread editable. Edible. I keep saying editable. Edible protocol. Okay. So we'll say define implementation of edible for, we got a loaf of bread. So when this happens, eat, we'll say bread character. What is it supposed to do? When eaten, a loaf of bread gives the character 5 health points and has no byproducts. Okay. Oh, so it returns a tuple. Okay. So nil and so they haven't given us a, like they've implemented character as a struct and it's got health and mana. They haven't given us like functions to like change health and mana, so I assume we'll need to do it in the map directly. Which is fine, but generally I would encourage people not to, like, if you're gonna have internal state of a struct, like you should usually provide functions to like mutate it. Otherwise you're leaking your implementation and that means you can't change the struct later, which depending on what you're willing to sacrifice, that may or may not be a problem. Okay, so health. So this is going to be character health plus how much? 5. All right. What are you complaining about? Bread is unused. Okay, well that's fine. I'll just do that. All right, cool. I'm gonna expand all these so we can see all the tests. And then I'll run all the tests. And task 2 looks good. Task 3, implement the editable protocol for mana potion item. When eaten, a mana potion gives the character as many mana points as the potion's strength and produces an empty bottle. Okay, so we'll say define implementation edible for mana potion. Or no, yeah. And then inside we'll say define eat and mana. Well, no, we're gonna need this one. Mana potion and character, and this is going to do something. So this is going to return an empty bottle, which we can just instantiate. Instantiate is a bad word. I shouldn't use that. And it's got the character. And similarly, we're going to use the existing character, and we're just going to change its mana to be character mana plus mana potion dot strength. And what are you complaining about? Oh, I need an extra people closure brace. All right, let's run all the tests. Task 3, task 3, task 3. Those all look good. All right, cool. So now we'll do potion. make an edible protocol for the potion item when eating poison. The poison item when eating a poison. A poison, that doesn't read well for me. Takes away all the health points from the character and produces an empty bottle. Okay, this is gonna be pretty similar. I'm just gonna copy this because I'm a lazy programmer, and poison, and this is going to take poison, and this is going to return empty bottle and their health. What did they say? Takes away all health points. So I'm just gonna say 0. There we're not using the poison, so I will mark that off. And we're gonna run all the tests. And that looks good. And we're done. That is it. Alright, cool. So I don't have specs, and you can see my editor is yelling at me very loudly because I don't have specs. But I don't want to do specs because then I'd have to build specs for all these. I don't know. Not doing specs. I'm gonna delete this because typically the Exercism analyzer usually yells at you about comments. Alright, so I'm going to upload this. Exercism submit RPG, and we'll see the. Looks like we passed, and we'll take a peek at the community solutions, although I don't see a lot of difference with us here. Yeah, they pretty much did what we did. Anybody else do anything different? So the only thing they did different was like they, inside of the function definition, pattern match, they took out strength directly, so that way they could just use, instead of mana potion dot strength, and they also use map dot update. That's a slightly different way to do it. That's fine. Okay. All right. I'm feeling pretty good about our iteration. So I am going to mark this as complete, and I'm going to publish my solution. And we have learned protocols. We have unlocked 2 different exercises. And we have learned protocols. Cool. Yeah, I think that's it for today. I want to thank you for watching. Hopefully you enjoyed yourself. And if you have any questions or feedback, please do let me know. Other than that, have a great day, and I will see you next time. Bye-bye.